Hello, my name is Shikib Mehri, and I'm a graduate student at Carnegie Mellon University. I'm here today to talk about evaluating open domain dialogue. Evaluation metrics shape the direction of research. We use them to compare between systems, which determines what gets published, and we use metrics to identify the weaknesses of systems, which determines what people work on. But evaluating dialogue is really difficult for several reasons. First of all, dialogue has an inherent one-to-many nature. For each dialogue history, there are many valid responses. And what this ultimately means is that we can't compare to a reference response. The reference response isn't the only valid response, and you shouldn't unfairly penalize a system for generating a perfectly valid response that it just happens to be different from the reference response. Unfortunately, this means that most existing metrics for language generation won't work well. Things like BLEU and F1 score, which just compute word overlap between a generated and a reference response, don't work well when a perfectly valid response might be completely different from the reference response. The next reason dialogue evaluation is hard is that the notion of quality in dialogue is multifaceted. A response isn't just good or bad, and you can't reduce dialogue quality to a single number. Especially for the purposes of interpretability, we should be measuring multiple qualities of dialogue, like relevance, interestingness, and fluency, to name a few examples. The third reason dialogue evaluation is hard, is that dialogue is inherently interactive. Dialogue systems are meant to have a back and forth interaction with the user. However, research largely focuses on static corpora, which reduces the problem of dialogue to mapping a dialogue history to a response. And the static environment means that we can't really assess some properties of dialogue systems, just because we need an interactive environment to assess them. This includes things like long-term planning, error recovery, and coherence. So evaluation is important, and evaluation of dialogue is really difficult. We can't compare it to a reference response. We should be assessing many aspects of dialogue quality, and we should be evaluating in an interactive manner. One thing that I should say is that the only perfect evaluation mechanism is human evaluation. And ultimately, when you really want to get a sense of how a system is doing, you should rely on human evaluation. But human evaluation is both time-consuming and costly, which means that we can't use human evaluation during development for things like hyperparameter tuning, and we can't use human evaluation for things like analysis. For example, if we have a bunch of conversation logs and we just want to automatically, quickly identify the erroneous dialogues. So there's still a really big need for an automatic metric for evaluating dialogue, even though, and I emphasize this as much as I can, everybody should be using human evaluation to do the final assessment of their systems. So over the course of this talk, I'm going to be talking about two recent papers. USR, an unsupervised and reference-free evaluation metric for dialogue generation, which was published at ACL this year, and unsupervised evaluation of interactive dialogue with Dialog GPT, which was published at SIGDAL this year. So let's talk about USR first. Essentially what we did here was we trained response generation models on two open domain chit-chat datasets, the topical chat dataset and the persona chat dataset. Once we have these models, the question that we're trying to answer here is, how do we best evaluate these models on the test set? Of course, we can use existing reference metrics, but then we also present a novel reference-free metric, which is USR. So the very first thing that we have to do is, because we want to assess the performance of automatic evaluation metrics, we need to compare those metrics against human judgments. So we need to collect human quality annotations. The way we do this is we first generate responses from several models. we have humans annotate those generated responses for several different dialogue qualities. And then once we have the metrics, we measure the correlation of the automatic metrics against the human judgments that we collected. So how do we generate these responses? First of all, we framed response generation as the task of going from a dialogue history and some knowledge to a response. This knowledge in persona chat is the persona. In the topical chat dataset, it is some interesting fact. For persona chat, we collect 5 responses: the original ground truth, a new human-generated response, and then responses from 3 types of models: an LSTM language model, an LSTM sequence-to-sequence model, and then a key-value memory network. For topical chat, we collect 6 responses. Again, the original ground truth, a new human-generated response, and then a transformer model with 4 different decoding strategies. Once we have these different responses, in total we have 60 dialogue contexts, which means that we have 360 responses for topical chat and 300 for persona chat. We annotate these responses for 6 dialogue qualities. These qualities are carefully defined with examples for every single answer that somebody could give, and then each response was also annotated by 3 different people. We annotate for 6 different qualities: whether a response is understandable, whether a response is natural, whether the response maintains context, whether the response is interesting, whether it uses knowledge, and then finally an overall quality, which tries to assess the annotator's overall impression of the response. Here are the results of the annotation on the persona chat responses. What I want to highlight is that the new human-generated responses outperform everything else, closely followed by the original ground truth. The models are a bit of ways away, with the LSTM language model being a little bit lower than the other models. And what I want to show here is that we have a widespread of performance. And this is really important because when you're designing an evaluation metric, you don't want it to only work for really good models or really bad models. You want it to be able to effectively assess responses across the entire array of performance. Okay, so now that we have these annotations, let's talk about the metric. So we want to build a metric that does not compare to a reference response, assesses several aspects of dialogue quality, and does not use any labeled data for training. So because we don't want to compare it to a reference response, this means that we need a model-based metric that takes as input some information like the dialogue history and knowledge, and then a response and output some score. Because we want to assess several aspects of dialogue quality, this means that we should probably have multiple models that try to capture different qualities of dialogues. And then because we have no label data, this means that we should use self-supervised training to approximate quality. So that's what we do. We take a pre-trained language model, Roberta, and we fine-tune it on self-supervised tasks that aim to approximate the different dialogue qualities that we want to capture. So for tasks like for qualities like understandable and natural, our task is masked language modeling. For interesting and engaging, our task is dialogue retrieval. And then for uses knowledge, our task is fact to response selection. So in masked language modeling, what we're trying to do is we have the dialogue context and then we have the response, and they're concatenated to each other. We go through every single word of the response and we sequentially mask every single word. And then we compute the probability of the word that we masked. In doing so, we're essentially getting a sense of the likelihood of the response following the dialogue context. We add up the score for the masking of every single word, and that gives us the MLM score. For the dialogue retrieval models, we fine-tune Roberta for dialogue retrieval, which essentially means we train it to take as input a dialogue context and then a response, and try to predict the probability that the response follows the dialogue context. We can then use this model to approximate relevance and interestingness. And then to measure whether a response uses knowledge, we fine-tune Roberta to predict whether a response is conditioned on some knowledge. We then use the model to predict to approximate to how extent the response uses the knowledge. So to sum up the user metric, we have these 5 different qualities, and we have 3 different models. These models aim to approximate the different qualities. Once we have a score for every single one of these qualities, we pass them through a regression that is trained on the data that we collected. And by computing the regression, we get the overall quality score. Before I talk about the performance of the user metric, I just want to briefly mention some existing evaluation metrics that we compare to. We compare to word overlap metrics like F1, Blue Score, Meteor, and also embedding metrics like Skip Thought and Bird Score. So first, I'm going to show the correlation with human judgment for the topical chat data. As you can see, the user metrics are shown in green, and the overall user metric, which is the output of the regression, is the best correlated with human judgment. Of the embedding-based metrics, Bird Score is the best performing, and of the word overlap metrics, Meteor is the best performing. For persona chat, we see that overall, all of the metrics do worse than they did on topical chat. Except we see that the user metric is still significantly higher than everything else, almost double the correlation of every other metric. So to sum up the contributions of this work, we developed USER, which is an unsupervised reference-free evaluation metric that measures multiple qualities of dialogue, exhibits strong correlation with human judgment, and can be easily extended to other open domain data sets because it's only self-supervised and doesn't rely on training data. It's also open sourced, and we also release our human annotation to facilitate the development and assessment of new metrics. So now I'm going to talk about the work that we did after USER. And really the motivation for this work was that even though USER works pretty well, and it accomplishes a lot of what we want in an evaluation metric, it still lacks a lot of desirable properties. First of all, USER was built for evaluating response generation on a static data set. It can't really work in an interactive setting because the interactive conversation deviates from the data set that we would do self-supervised fine-tuning on. The other problem with USER is that we wanted to evaluate different aspects of dialogue, but ultimately USER only has 3 distinct models and measures 5 different dialogue qualities. So is it really measuring enough qualities of dialogue? To address these problems, we worked on fine-grained evaluation of dialogue. Essentially what we did was we took a collection of interactive dialogues between humans, Mina, and Mitsuku. We annotated these dialogues for 18 different dialogue qualities to produce the fed dataset. We then present an evaluation metric that can effectively measure these 18 different qualities, which we call the fed metric. These are the list of dialogue qualities that we measure. We measure both turn level qualities and dialogue level qualities. Turn level could be things like interesting, relevant, fluently written, semantically appropriate, and then dialogue level qualities try to look at the entire dialogue rather than a specific response. Things like coherence, diversity, topic depth, informativeness. Okay, so to annotate this data set and collect the fed data set, what we do is we take interactive dialogues released with the Mina paper, These dialogues are human Mina, human Mitsuku, and human human. We take 124 dialogues and we annotate them. For every single dialogue, we select 3 turns and do 3 turn-level questionnaires. Multiplied by 9 turn-level qualities, this gives us 3,348 data points for turn level. And then for each dialogue, we do 1 dialogue level questionnaire on the entire dialogue. And with 11 qualities, this gives us 1,364 data points. Every response was annotated by 5 different people. So to briefly summarize the quality, I'm not going to go into too much detail, and you can find more detail in our paper. For turn level, we see that Mina outperforms human and Mitsuku, and then human and Mitsuku are roughly around the same performance. What we can do is we can train a regression over the turn level qualities and aim to predict the overall impression score. And in doing so, we can look at the weights assigned to every single one of the fine-grained qualities to assess what the most important qualities for predicting the overall impression is. And we find that interestingness, relevance, and fluency are the most important fine-grained metrics to get a higher overall impression score. For dialogue level, we see that humans outperform Mina, and then Mina outperforms Mitsuku. The most important qualities, again, are coherence, likableness, and the system being understanding of the user. Okay, so let's talk about the evaluation metric. We're in a really challenging position here because we have no training data, we have no reference response, and we can't do what we did for user. We can't come up with 18 different self-supervised models. Because how do you come up with a task to measure topic depth or semantic appropriateness, for example? So to explain what we do to come up with a fed metric, I'm going to walk through 2 pieces of intuition. First of all, the next user utterance is important for judging quality. For example, if the conversation so far is the user asks, "How are you today? I was just watching the football game," and then the system responds with, "Did you know cats sleep for 18 hours a day?" And then the next user response is, "Huh? That's not relevant at all." By looking at this next user response, we can get a sense of the quality of the last system response. And we did this work last year as part of Eskenazi et al. And we found that by doing this, by looking at the next user response for task-oriented dialogues, we can better evaluate the quality of a particular system response. But in open domain dialogue, what are the odds that the user says something useful about the quality of the last system response? If we rely on the user calling out the system response for being bad, we might really only capture the worst of the worst responses. The next piece of intuition is that large pre-trained models, such as BERT, have been shown to implicitly capture world knowledge. Dialog GPT, which is another large open-sourced pre-trained language model, claims human-level response generation capability. So this leads to the hypothesis that Dialog GPT, in the process of learning to generate human-level responses, has implicitly captured some notion of dialogue quality. And now what this means is that just as a user is more likely to respond with, "Huh, that's not relevant," to an irrelevant response, Dialog GPT, which has human-level response generation capability, should be able to do the same thing. So essentially for the Fed metric, what we do is we take the dialogue history, and then we use Dialog GPT to evaluate the log likelihood of generating both positive and negative follow-up utterances. So for example, if we're interested in measuring how relevant a response that is a response is, what we do is we assess how likely is it the Dialog GPT produces cool, very relevant, versus how likely is it that Dialog GPT produces that's not relevant? And by subtracting the log likelihoods from each other, we ultimately get the metric score. If the metric score is higher here, it suggests that it's more likely the Dialog GPT is going to produce something like cool, very relevant. Versus if the metric score is lower, it suggests that it's more likely that Dialog GPT would produce that's not relevant. And what this really means is that we're relying on Dialog GPT to have captured some notion of relevance and therefore know when it's better to respond with the positive follow-up utterance versus when it's better to respond with the negative follow-up utterance. So for every single of one of the 18 different dialogue qualities, we manually come up with between 0 to 4 positive and negative follow-up utterances. For example, for the interesting quality, one of our positive utterances is, wow, that's so interesting. And then one of our negative follow-up utterances is, that's really boring. And then to measure the overall impression, we take the average of all the fine-grained scores. We evaluate 4 different Dialog GPT models, medium and large, and then also fine-tuned from GPT-2 versus fine-tuned from scratch. So here are the results. Our turn level correlations range between 0.11 and 0.43. The highest correlations that we obtain are for qualities like interesting, engaging, and specific. And then the overall turn level correlation is 0.21. For our dialogue level correlations, we see scores between 0.25 and 0.52. The highest correlations are for topic depth, diversity, and informativeness. And then the correlation for the overall dialogue level quality is 0.44. And I really want to say here, there's room for improvement on these scores, but I think it's really surprising that we were able to get such, even remotely reasonable scores with a model that we did not fine-tune, that is entirely unsupervised. And this really validates the hypothesis that Dialog GPT, in the process of learning how to generate responses, has learned some notion of dialogue quality. And by using this strategy with the follow-up utterances, we're effectively extracting this notion of dialogue quality that has been implicitly captured by Dialog GPT. So the contributions of this work: we developed FED, which is an unsupervised fine-grained evaluation metric that measures multiple fine-grained qualities of dialogue, exhibits strong correlation with human judgments, and because it's unsupervised and only relies on manually written follow-up utterances, it can be scaled to other qualities. We also released the FED dataset to facilitate the development and assessment of new evaluation metrics. We also open sourced the code, which you can find here, and it's honestly really easy to use. You just load the models that you want to use, and then you pass the conversation into the evaluate function, and you get a dictionary of scores at both the turn level and the dialogue level. And here are the links for the code and the data from both projects. Thank you for your attention.